Well, hello pre-calculus students and seekers of general truths. In this video, what I would like to discuss and try to explain to you is the binomial theorem. Now, we will get to the theorem at the end here. You can certainly do a search on it and see what the theorem says, but what I'm trying to do in this video is show you the rationale for where the theorem comes from. And to do that, we always start with some very basic examples. And so let's do a little bit of algebra here. So let's say I have a binomial, right? And this is where the name comes from, a plus b quantity squared. Well, this is really a plus b times a plus b. And I'm giving you all of the nitty-gritty details here for reasons that will be clear in just a minute. Once we distribute this, we get a squared, right? Plus AB plus another AB and then plus B squared. Okay. And actually I'm going to give you some yet even more nitty-gritty details. Rather than saying A squared, I'm going to say A times A. Instead of B squared, I'm going to give you B times B. Okay. And then once we have this, right, we can group this together. And I'm going and we can say that these are my like terms. So I'm going to get a squared plus ab times 2 plus b squared. Okay. All right, let's keep going. A plus b to the third power. Okay. Now, before we try to expand this, let's think about what terms we're going to have. So going back to the first example, when we square the binomial, every single term here has two factors. Okay. In this particular case, when we cube it, every single term is going to have three factors. Right? So the first term we're going to have here is going to be a times a times a. Okay. So let's expand this and then maybe I'll clarify a little bit more. So this is really a plus b times a plus b squared. Right. So this is a plus b. And a plus b squared we know is this up here, right? A times a plus a times b plus a times b again plus b times b. And then now we distribute that, right? So we say a times the first term, so that gives us triple a times the second term, that gives us two a's and a b, a times the third term, that gives us another two a's and a b, a times the last term, that gives us one a and two b's. Okay? And then we do this one more time, b times aa, so that gives us two a's and a b again, and then b times ab, so that gives us 1a and 2 b's, and then b times the third term, that gives us 1a and 2 b's, and then finally b times the last term, that gives us 3 b's. Okay? So one pattern that we can start to extract from this is that every single term, when we cube the binomial, we're going to end up with three terms, with three factors. Three variables here in some way, shape, or form. Okay, well, and if we think about these, how these are arranged, right? Let me just give myself a little bit more space here. All right, so if we consider how we expand this binomial by cubing it, we see these terms here, and notice here that every term has some combination of A's and B's. Okay, so it's kind of like, you think about this, you have three slots for every term, right? Has three slots. And you can fill these slots only with A's and B's. They can be duplicated, but you can only fill them with A's and B's. So one way that you could fill them with is all A's. Okay. And if you fill these with all A's, there is only one way for you to do that, So you get 1a to the cube, to the third power. Then another way that you could fill them is with 2a's and 1b. Okay. Well, 2a's and 1b, and it doesn't really matter what order. This is all multiplication, so we can eventually rearrange them again to look the way we want. So it's kind of like you have 3 spots here, and you're going to choose 2 of them to be an A. So there's going to be 3 choose 2 different ways to do that. Okay, 3 choose 2 is just 3. So you're going to get 3a squared b. And then if you want to have 1a and 2 b's with 3 empty slots, then it's the same thing. You can say it's 3 choose 1, or you can say 3 choose 2. It's the same number, and so that's just 3. So it's going to be 3ab squared. Okay. And just so you see that this makes sense, the a squared b's are right here. When you have 2 a's and a b, right, there are 3 of those. And then for you to have 2 b's and an a, there are 3 of those. Okay. And then finally, for you to have 3 b's, so for these 3 slots to just to be b, there's only one way to do that. And so this is 1b to the third power. Okay. So you see here that what we're really doing here is counting the number of possibilities for us to have these arrangements of a's and b's. It's the same as a combinatorial problem, except that with the additional fact that these a's and b's really mean multiplication. So we can group them together into a squared, b, a, b squared, and so on. Right? So let's continue here, and let's look at another, a more complex example here. And this is where, once we get to the power of 4, this is where the binomial theorem really comes into play and becomes useful, because it is a real pain to start multiplying things out 4 times. Okay, but let's use what we know here. If we were to expand this, every single term is going to have 4 factors, right? In other words, every single term is going to have 4 blanks. Okay, and let's think about all the possibilities. First, change up the color here. We could have 4 a's, right? And there's just one way to do that. Right, that's it. So that tells us that a to the 4th is going to be a part of this. Okay. Then another possibility is that we could have 3 a's and 1 b. Right? And how many ways are there to do that? Well, 4 choose 3. Okay, because it's like we have 4 blank slots, and we want to choose 3 of them to put an a in, and then the 3rd slot we're going to put a b in there. So that will give us a to the 3rd b, right? Because 4 a's and 1 b, and 4 choose 3 is 4. Okay. Then another way that we could do this is we could have 2 a's and 2 b's. Okay. So that there are 4 choose 2 different ways. So it's like you have 4 spots and you want to choose 2 of them to be an A. 4 choose 2, so this is going to be a squared, b squared. Okay. And 4 choose 2 happens to be 6. Okay. And then you could have 1a and 3 b's. Okay. And so this is 4 choose 1, right? Because there are 4 slots here, and you could choose you could choose one of them to be an A. So 4 choose 1, so this is going to be a, b to the 3rd, and there are 4 different ways to do that. Okay? And then finally, you could have 4 b's. So this is 4 choose 4, which is just 1. Okay. Or you could say this is 4 choose 0, however you want to represent it. So we could have b to the 4th. Okay. So that means a plus b raised to the 4th power is the sum of all these terms. It's a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab to the 3rd plus b to the 4th. Okay.